Alright guys, in today's video we're going to be working on a Porter Cable 5500 watt generator that doesn't generate. There's no electric output. This is a BSV550-W Type 0, but this video is going to apply to the Type 1 as well as the BSI model. I'm going to show you the most common root cause for this type of problem given the test that I'm going to take you through. Okay, to run this test you're just going to need a simple multimeter set to AC voltage. My assistant's going to be doing this test because I wasn't on site at the time, and you're going to connect the terminals to the 120 volt outlet and you're going to measure voltage. You can see here we're measuring just a little bit over 1 volt. Now I asked her to check all of these, not because you need to for this particular test, but just while we're here, let's make sure all of these are correctly wired up. Reading less than 2 volts like this points to a particular common failure condition, and what we're going to do to diagnose whether we're right with this is we're going to go to the end cap of the generator, which is this little guy right down here, and we're going to pull him off to do some additional diagnostics. Alright, so here's a parts explosion for what we're after here. Now this is a diagram of the Type 1, so this Type 0 in the video doesn't have these extra outlets on the end cap. But we want to take the two T15s out, pull the end cap out of the way, and what we're after is access to this capacitor right here. These particular models do not have a voltage regulator design. They're non-inverted. So the only thing that could fail for this type of voltage readout that we're seeing is either a problem with the capacitor or a problem with the diodes that are here. There could be more severe problems in the wiring, but you don't tend to get the kind of voltage reading we just saw. So that's what we're after, is this capacitor. Alright, to remove the end cover, we're going to take these two T15 screws out. Once we get these two screws removed, there's going to be a wiring harness bundle on the other side, and this guy's going to want to dangle. So get something to support the end cap after you get it removed so that you can set it to the side. And also, again guys, make sure the engine is not running for this particular exercise. Now this capacitor that's located right here, this can be dangerous. This is a high voltage problem. So be careful how you hold it. Let's take note of the writing that's on that capacitor. We can see this is a 40 microfarad 370 volt capacitor. Take note of the dimple that's pressed into this OEM version for the orientation of the wiring harness, and remove one of the terminals. Then we're going to take our multimeter and we're going to set it to the capacitance measurement. On this particular Intek model, it can measure up to 10 millifarads, which is 10,000 microfarads, so it's perfect for this type of test. Go ahead and carefully put the probes on the capacitor. Again, you don't want to touch and create a circuit with yourself because it could short yourself out, and you can see we're reading less than a 1 microfarad value there. So let's do that again just to get a good view. We're reading about 0.03938 microfarads. So this is a bad defective capacitor. Now we're going to replace that with an OEM capacitor, a GS0748, right from DeVilbiss. This is a part of the Stanley Black & Decker company, Porter Cable, DeWalt, all these companies are part of that. And here's our replacement OEM GS0748 40 microfarad capacitor. We're going to use OEM because we got over 20 years out of the original one, but more importantly, it's going to fit in this crevice perfectly with physical dimensions. Now this little guy's got a couple of dents and dings from shipping, but that's okay. And you can notice there's a little vent hole here we can use, just like the dimple, to orient where we want to put these terminals. So let's go ahead and test the new capacitor to make sure it's okay. You can get a dead one out of the box, and you can test this without even removing it from the plastic bag as well. And we can see with the same test, just give the capacitor time to charge up, we're getting 39.64 microfarads, so that's perfect. You know, it's within the tolerance level of the capacitor. So this one's good, the original one's bad. Transfer the terminal that we pulled off before for the test of the old one, and then transfer the remaining terminal off of the old one, and then this guy will sit right back in to that crevice that the original one was sitting in just perfectly. There's a little retainer that holds it on the bottom. And then we're going to go put the end cap back around, making sure the wiring harness isn't going to be crimped or caught. You can see there's a wire kind of like on the lower left hand side. We want to make sure we get in there as well. and then we can put these T15 fasteners back in. I'll show you the torque value for those in a moment. There is a torque value on those, but we need to take a look at this label. I want to show you the label on this guy. Okay, taking a look at the label, here's the model number information that we're working on. All right, we're going to put those two T15s back in. We'll torque them in a moment, and now we're going to go retest our voltage output and see if the new capacitor fixed the problem. All right, guys, here's another diagram from the service information. This is a type 0 diagram. You can see by the way the end cap looks matches ours. I'm showing you this so that you can just see these two T15 fasteners. The torque value on those guys is 45 to 55 inch-pounds. And I went with 55 inch-pounds on this. And the reason there's a torque value in here is, of course, to make sure these guys don't wiggle loose with the operation of the unit and have this end cap pop off. All right, guys, let's see if this made a difference. Let's put our meter back in AC voltage mode. With the engine running, of course, we're going to remeasure our output. All right, so it's working now, but it's hot. We got 146, 147 volts. We shouldn't have more than 126 here, to be honest, right? So we're just going to go ahead and again see if we're getting a consistent reading out of all these outlets just because we're here. But there's more work to do. This is probably because the RPMs are too high. The owner took this to a lawnmower shop to try and get it fixed before they contacted me. It's probably possible that those guys messed around with the fixed speed governor on the engine. We'll go take a look at that and see if we can make an adjustment there to get the voltage back down. But, you know, in general, we can hook up a light. You know, that's the only thing I would try with this particular situation until we fix the voltage. But, you know, we've got outputs. We fixed the original problem. Now we got to do some fine-tuning and adjustments to get it back within specification. All right, this particular generator has a Briggs Stratton Vanguard engine. And so what we're going to be looking for to try and get the voltage down is to find the mechanical governor. It's right behind the engine where it mounts up to the generator. And there's a lock nut. If we zoom in this picture from the service manual here, there's a lock nut that's holding this arm onto this shaft. And at the combination of a 10 millimeter wrench and a screwdriver, we're going to adjust this piece here to see if we can get the voltage back down within the specifications. We want that voltage to land somewhere between 117 volts and 123, 125. All right, to get access to this governor, we got to take this metal frame piece off right here and this black plastic trim that runs along the front of the carburetor levers. To get the black metal piece off, there's two 10 millimeters. There's one right here with the clamp to the fuel line, and there's another one right up in the front near the power head. To get the black plastic off, there's a 10 here on the corner that goes into the metal frame, and then there's another 10 right here on the edge that goes into a bracket. Now the levers are going to be in the way of the air cleaner cover to get this black piece of plastic off. So you're going to have to take the air cleaner cover off too. There's two thumb screws here and here. Just twist them counterclockwise, lefty-loosey, pull that off. With the air cleaner cover out of the way, you'll be able to pull this trim piece off, and then the black piece will come out right with it, and you won't have this clearance problem. All right, with that out of the way, this is the governor assembly. This kind of L-shaped bar is hooked up to the throttle on the carburetor, and this is what moves around as the engine's running. This is the lock nut you saw in the service manual photo, and then there's the slotted shaft. So what you're going to do is let me zoom in here. What you're going to do is you're going to get a 10 millimeter wrench for this nut and a screwdriver. You're going to hold this bar that you see towards the left-hand side with the rod, the left-hand side of this view in the image. You're going to bring this wrench in here while you hold this bar pulled towards you as you see in the photo here, in the shot here. Then you're going to turn this nut clockwise to loosen it. Clockwise to loosen it. After you get it loosened up, you can see there's like a little clip under the rod that'll move too. Then you're going to take a screwdriver and you're going to turn this shaft counterclockwise until it stops all the way. Once it's turned all the way, you're going to retighten the nut. Now the way it's being shown here, it can be a little bit more difficult because if the nut makes the shaft turn like it just did, you're going to have to stop and get the screwdriver again. If you can get a way to have somebody help you hold the lever, then you can use two hands. You can hold the screwdriver on the shaft while you use the wrench to tighten it up and lock it down, and you won't have this problem of trial and error like this. But you can do it the way we're showing here, but I'd recommend, if you can get a helper, that you do it the other way so you don't have to go back and forth, right? Because as you turn this nut, it's going to have a tendency to turn the shaft. All right, we've got this guy running. He's not happy, but we've got the output down, which means we don't have an internal problem. So we've got it down from 140 to around 104. That's an improvement, but now the voltage is too low. If you take a look at the RPMs on this digital tachometer, we're only reading around 670 to 600. It's kind of bouncing around, and the engine's just on the verge of stalling. All right, second time's the charm. She's happy now. She's idling nice and good. Our output's a little higher than I would like. I'd have it like it closer to 124, but we'll take this just because it's so finicky. If we take a look at the RPM, we're around 1,000, 1,100, so that's kind of like the sweet spot area for it to be stable. So this project's all wrapped up. If you guys thought this was helpful and it saved you some time and money, I appreciate you paying it forward by hitting that like button. Go ahead and leave a comment below if you got a question, and I'll try to help. And as always, thanks for watching.